On June 17, 2026, ID Quantique and IONQ announced the launch of Clavis XG Multiplex, a hardware solution designed to enable quantum key distribution deployment over existing metropolitan fiber networks. The innovation represents a significant breakthrough in practical quantum security by allowing quantum keys and classical data to coexist on the same fiber infrastructure, eliminating the requirement for costly dedicated quantum fiber lines. This development dramatically reduces the deployment barriers for organizations seeking to implement quantum-secured communications across metropolitan areas. By leveraging both classical and quantum capabilities, the solution provides enhanced protection against future cryptographic threats while maintaining compatibility with existing network infrastructure. The partnership represents a strategic convergence of two leading quantum technology companies, combining their respective strengths. This advancement is expected to accelerate enterprise adoption of quantum key distribution technologies for critical infrastructure protection. According to analysis released in June 2026, the global GPU-as-a-service market is experiencing substantial growth as enterprises rapidly accelerate investments in artificial intelligence, machine learning, and high-performance computing capabilities. The market, valued at $5.1 billion in 2026, is projected to expand significantly to $14.4 billion by 2033, representing a compound annual growth rate of 16%. This expansion is directly fueled by the proliferation of AI-driven applications across virtually every industry segment, requiring dedicated computational resources. The GPU-as-a-service model provides organizations with flexible, cost-effective access to powerful computing infrastructure without substantial capital expenditure on dedicated hardware. Major cloud providers and specialized GPU vendors are responding to this demand surge by expanding and diversifying their GPU-backed service offerings. The market dynamics reflect the fundamental shift toward on-demand, scalable infrastructure for supporting enterprise-wide artificial intelligence adoption and deployment. In June 2026, the semiconductor industry is experiencing a fundamental transformation as artificial intelligence and machine learning become integral to the chip design process itself. Machine learning algorithms are accelerating simulation and design optimization, dramatically reducing the time required to iterate on complex semiconductor designs. Infineon recently received industry recognition for implementing generative AI and multimodal language models to automate test engineering workflows, achieving approximately 80% reductions in test execution time. Leading chipmakers including Google and NVIDIA have embedded AI optimization techniques throughout their GPU and processor design methodologies, resulting in superior performance characteristics. Specialized semiconductor companies like Groq and Cerebras are pioneering novel chip architectures specifically optimized for AI inference workloads, moving computation closer to data sources to eliminate traditional bottlenecks. Industry analysis indicates that 2026 represents a critical inflection point, where hyperscalers are transitioning from reliance on general-purpose GPUs toward custom silicon development, creating what experts describe as the ASIC acceleration phase of AI computing. As of June 2026, WebAssembly has transitioned from experimental browser technology to a production-ready universal runtime platform accepted across the entire computing stack. The stabilization of WASI Snapshot 2 in 2025 and the advancement toward WASI 1.0 by late 2026 provide a comprehensive standardized interface allowing WebAssembly modules to access system resources like files, networks, and environment variables with sandboxed security guarantees. This standardization enables developers to write code once in WebAssembly format and deploy it unchanged across an unprecedented range of environments, including web browsers, cloud functions, edge computing nodes, and embedded systems. The significance of this shift was underscored when Akamai, the world's largest content delivery network provider, acquired Fermyon to integrate WebAssembly-based serverless computing into its global infrastructure. Performance metrics demonstrate WebAssembly's efficiency advantage. CISA Euro modules initialize in milliseconds compared to container startup times, while consuming orders of magnitude less memory. Current adoption metrics indicate approximately 5.5% of websites accessed via Chrome browsers already utilize WebAssembly, demonstrating rapid market penetration. Industry forecasts released in June 2026 indicate that global humanoid robot shipments are projected to experience exceptional growth exceeding 700% during the calendar year. This remarkable expansion reflects the maturation of physical artificial intelligence, Euro technology, that brings genuine machine learning and reasoning capabilities to robotic systems, enabling them to dynamically adapt and respond to novel situations in real-world environments. The convergence of advanced software frameworks, improved sensor technology, and more accessible hardware platforms is democratizing humanoid robotics development across manufacturing, logistics, service industries, and autonomous systems deployment. The commercial viability of humanoid platforms has been significantly enhanced by pricing innovations, with entry-level development platforms now available below $3,000, reducing barriers for both enterprises and researchers. Advances from major battery manufacturers like CATL have solved critical runtime limitations, enabling extended autonomous operation necessary for practical deployment. The transition from manually programmed robotic behaviors to AI-powered physical intelligence represents a fundamental shift in automation capabilities and is driving unprecedented commercial interest. In June 2026, Kubernetes 1.35 introduces significant advancements to dynamic resource allocation, with binding conditions graduating to beta status, directly addressing the evolving requirements of artificial intelligence and machine learning workloads. As GPU hardware transitions from specialized to default compute paradigm across cloud infrastructure, traditional Kubernetes monitoring and optimization metrics based on CPU and memory consumption are becoming inadequate. The enhanced dynamic resource allocation capabilities enable sophisticated scheduling algorithms to intelligently distribute demanding AI workloads across heterogeneous hardware resources, reducing operational complexity and improving resource utilization. Healthcare organizations are particularly benefiting from Kubernetes, self-healing mechanisms, and automated scaling capabilities, which ensure continuous operation of mission-critical medical software and patient data processing systems. A significant architectural evolution is underway, with the emergence of serverless container models that combine Kubernetes containerization benefits with on-demand scaling and pay-per-use cost models. This hybrid approach enables development teams to deploy containerized services without managing underlying infrastructure, effectively combining the operational simplicity of serverless computing with the portability and flexibility advantages of containerization. The evolution from 5G to 6G communication networks is fundamentally transforming autonomous vehicle capabilities by enabling unprecedented performance characteristics critical for next-generation transportation systems. 6G networks are achieving sub-millisecond latency targets essential for real-time cooperative perception among fully autonomous vehicles, allowing sensor fusion and coordinated maneuvering that would be impossible with 5G constraints. The theoretical data throughput capacity of 6 gigabits euro, exceeding 350 gigabits per second, with ultimate limits approaching 1 terabit per second a euro, enables simultaneous operation of AI-driven traffic management systems, immersive vehicle experiences, and advanced autonomous coordination protocols. Security implementation leveraging quantum key distribution provides cryptographic protection for vehicle-to-everything communications against current and future cryptanalytic threats. Emerging research is exploring particle swarm optimization techniques that enable vehicle fleets to coordinate behavior similar to biological swarms, distributing intelligence across the network rather than centralizing decision-making. The combination of 6G connectivity, edge computing capabilities, and advanced AI creates the infrastructure foundation necessary for Level 4 and 5 autonomous vehicle deployment and the broader intelligent transportation ecosystem transformation. Biocontainers represent a transformative approach to standardizing computational environments in bioinformatics research by encapsulating complete bioinformatics tools along with their libraries, dependencies, and operating system configurations. By leveraging established container platforms such as Docker and Singularity, biocontainers solve one of scientific computing's most persistent problem, Twesa Euro, ensuring that analytical workflows execute identically across different computational environments, from personal workstations to high-performance computing clusters to cloud infrastructure. This standardization eliminates the laborious and error-prone process of manual software installation, dependency resolution, and platform-specific troubleshooting that has historically consumed significant research time. Kubernetes container orchestration platforms enable bioinformatics teams to deploy containerized analysis pipelines at scale, processing massive genomic and proteomic datasets with automatic resource allocation and load balancing. The built-in health checking mechanisms in Kubernetes Euro, specifically liveness and readiness Probisa Euro, provide automated monitoring, ensuring that containerized bioinformatics applications remain responsive and available. The adoption of biocontainers significantly accelerates scientific collaboration by enabling researchers from different institutions to share standardized computational environments with complete confidence in reproducibility and consistency. The semiconductor industry is experiencing a fundamental architectural shift in 2026 as monolithic GPU designs give way to specialized chiplet architectures optimized for specific artificial intelligence workload characteristics. The diversity of AI applications SASA Euro, spanning large language models, image generation, video inference, and search optimization a Euro, has made design specialization economically attractive at scale. Chiplet architectures enable semiconductor companies to mix and match computational components, memory subsystems, and I/O interfaces from different manufacturing sources and process technology nodes, creating previously impossible levels of customization. Leading technology companies have launched custom silicon initiatives aligned with this strategy. Google developed specialized tensor processing units, Microsoft created the Maya processor, and Amazon built Trainium accelerators, each optimized for distinct computational patterns. Emerging chiplet innovators like D-Matrix have achieved remarkable results by tightly integrating ultra-low latency memory directly with computation resources, optimizing specifically for inference workloads such as video generation and prompt processing. This modular design approach dramatically accelerates development timelines compared to traditional monolithic die fabrication, enabling faster iteration and deployment of optimized solutions. The chiplet paradigm represents a foundational shift in how semiconductor companies conceive of and manufacture computing systems. Healthcare organizations are increasingly surmounting historically significant barriers to Kubernetes adoption, unlocking substantial innovation benefits for medical technology platforms. While Kubernetes adoption in the medtech sector has been constrained by resource requirements and complex regulatory compliance challenges, organizations that successfully implement the platform are discovering dramatically accelerated development cycles and improved operational reliability. Containerization through Kubernetes enables healthcare software development teams to rapidly iterate and deploy new capabilities while maintaining strict HIPAA compliance controls and security standards. The platform's automated scaling and self-healing capabilities ensure that mission-critical healthcare applications remain continuously available even during hardware failures or unexpected demand spikes, a requirement absolutely critical in medical technology environments. Container Health Checks a Euro. Specifically, Kubernetes Liveness and Readiness Probisa Euro enable automatic detection and recovery of application failures, ensuring that patient data processing and electronic health record systems remain responsive and reliable. The containerized approach significantly reduces operational overhead compared to traditional virtual machine deployments, lowering infrastructure costs while improving development velocity. Healthcare organizations successfully implementing Kubernetes are achieving faster innovation cycles, improved security posture, and lower operational costs, positioning them for more competitive and responsive medical technology platforms. Thank you for watching. Please do like and subscribe for more content and stay updated with the latest technology news.